All right, so what if we have a tangent even and a secant odd? Well, what that means is that we're going to be taking that tangent power that's even, and we're going to be replacing it with its Pythagorean identity for secant. So, like this. This is the technique that you want to use. Secant squared theta minus 1, secant theta, d theta. And you don't have to remember all of these things as if you see this, do this, if you see this, do this. Just remember all the different techniques and throw something at it. Something's going to stick eventually. And then now, if we distribute that, you can see that we get our individual secants, and that's what we're going to be using. So we have secant cubed theta d theta minus the integral of secant theta d theta. So if we find those two individually, so we're going to now just basically break this up into two different integrals. You're going to go out and you're going to find what does that equal. And then we're also going to find out what does this equal. Well, we already know this one. This one is the negative natural log of secant theta plus tangent theta. It's sitting right up there in front of us. And we also now need this one. And so this one we would do like we did before. So if you remember the previous videos, in those previous videos we did the secants all by themselves. So you would want to use these techniques as the second part. And there is our secant cubed theta d theta. And we did all of this work by integration by parts and then distributing, and then we go, okay, well that's a secant cubed, we can add it over and then distribute, and we end up with this. So this is what we're going to be using. And now I'm allowed to use it because I did it. Now you're not allowed to just say, oh, well I saw this here so I'm going to plug it in. No, you still have to do the work to find it. But if you've already done it, then yeah, you're allowed to go back and grab it. You don't have to do it again. You've already shown it on your paper that you're done. Why am I plugging in x? I don't know. Secant theta, tangent theta, plus 1/2 natural log secant theta. All right, and you can see that we have a like term here. This is a negative, and that one's a positive, and so we're going to end up with a negative 1/2. So our integral here is 1/2 secant theta, tangent theta, minus 1/2 natural log secant theta plus tangent theta plus c. And there you go. So the main idea is to break everything into secant squared because you have an even tangent. So it works perfectly. Distribute that whole thing out and then break them up in their individual integrals. And then you can go back and use the previous video to find out what each individual secant is going to become. And there's your answer. Now, what if you have a definite integral? Well, with definite integrals, you do exactly the same thing, but now at the end, you don't put plus c, you just plug the numbers in. And so I recommend just leaving them off until the very, very end and then plugging them in. That way, if you use integration by parts or anything else, it doesn't mess things up. So just leave them off until the end and then plug them in. That's my recommendation. There are other ways that you can do it though. So now if we plug this in, we get 1/2 secant pi over 4. Plus, oops, not plus, tangent. Minus 1/2 natural log. And now I'm going to put the 0 in at the end, so minus 1/2 secant 0 tangent 0 minus 1/2 natural log secant 0. Remember, these are trigs, so you do want to plug in that 0. It's not a polynomial where we had no constants. All right, so now the fun stuff. So we get, I'm going to just write above it, rad 2, 1, rad 2, and 1. Secant 0 is 1, tangent 0, so that's gone. So we can just cross that off because there's a 0. And then secant 0 is 1, tangent 0 is 0. So we end up with natural log of 1, and natural log of 1 is equal to 0. So that second part is all subtracted away. So we just have the first one. So this equals together, and by the way, that should have been a plus here, not that it mattered in this problem, but 1/2 rad 2, so that would be rad 2 over 2, minus 1/2 a natural log of rad 2 plus 1. And then now all we have to do is plug this in our calculator, and they match. There you have it.